Hello my viewers, you're welcome to Medical Science Lecture Room. Here we try to keep you informed on science and medical matters. In case you're new to this channel, please subscribe, turn on your notification button so that when new videos are made, you'll be first to be notified. Like the video if it's of value to you and also share it. Today's discussion will be on chemistry and the topic is ionic or electrovalent bonding. Let's begin. Ionic bonding or electrovalent bonding is a type of chemical bonding. Chemical bonding, we have basically two divisions. We have the ionic bonding and the covalent bonding. But today's discussion is on ionic bonding. But before we get deep into it, I would like to remind my viewers on the periodic table. The periodic table, briefly, it's a table of elements arranged in order of increasing atomic numbers. Now, this is a pictorial representation, a skeletal representation of the periodic table. The table has groups and has periods. Now, there is another video on periodic table, very explicit. So, I request my viewers to go check for that video. You have an adequate understanding of what a periodic table is. But for the purpose of comprehending or understanding the topic ionic bonding, we need to remind ourselves of what a periodic table is. Like I said earlier, it's a table of elements arranged in order of increasing atomic numbers. Now, like you have before you, here is a table. Like I said, this is skeletal diagram. We have, this is group 1, this is group 2, this is group 3, group 4, group 5, 6, 7, and 8. Now, if you go down the group, down this way along a column, you're going down a group. But if you go this way, it's a period. So this is period 1, this is period 2, this is period 3. Now, that's not what is of interest to us. Here, I want you to understand that the way the elements are arranged, we are having an arrangement where some elements are towards the left-hand side, while some are towards the right-hand side. So, as you move from the left side towards the right, some changes of properties occur, what we call periodicity. Now, you can have, when you move from left towards the right, you will see that ionization energy will change, atomic size will change. We will have a different discussion, a different day for that discussion. But for now, I want you to understand that the elements that are towards the left-hand side are metallic elements, while the elements that are on the right-hand side are more non-metallic. Now, if we are to define ionic bonding or electrovalent bonding, we'll be saying that it is a transfer of electron from one atom to another, usually from an electropositive atom to an electronegative atom. Now, back to this table, you remember, I want you to know that apart from this group of elements, the group 8 elements, and group 8 elements are called the noble or rare gases. These elements are stable. They are stable because their outermost shell or outermost orbital is completely filled. It's either the outermost shell is completely filled with two electrons, especially for the ones with only single shell, or it is completely filled with 8 electrons. When that happens, we say such an element has fulfilled its octet structure if it has a total of 8 electrons, or its duplex structure if it has a minimum of 2 electrons. Now, that is what you find for elements that belong to group 8, and such elements are not involved in any form of combination or any form of reaction. The reason is that they are stable, absolutely. But for the rest of the elements from group 1 to 7, at every point in time, they have a desire to become stable. And for them to be stable, they go into one form of chemical combination or the other, one form of electron transfer. And the essence or the reason for that is because they want to attain stability. So that chemical combination is important because elements at any point in time want to become stable, which is why they had to undergo this chemical combination. Now, let's go back to the definition of ionic bonding. We said ionic bonding is a transfer of electrons from an electropositive element or atom to an electronegative atom. That is telling you that the transfer is from metal to non-metals, because these elements at the left-hand side are more electropositive, while the elements towards the right-hand side, far the right-hand side, are more electronegative. So if the transfer is from electrons and atoms that are highly electropositive to atoms that are highly electronegative. It therefore means that the transfer is taking place from metals to non-metals. Okay, now again you need to understand that when those atoms that transfer their electrons, that donate these electrons, are therefore called electron donors, while the atoms that accept the electrons, of course we have said they are the non-metals, are therefore called electron acceptors. Now what happens after, again it's important for you to know that it is not all the electrons that are on the shell that are involved in this transfer. The electrons that are involved in this transfer are the valence electrons. The valence electrons are the unpaired number of electrons in the outermost orbital of an atom, or it is the number of electrons in the outermost shell of what? An atom. But the best definition is the number of unpaired electrons in the outermost orbital of what? An atom. So it means therefore that when there is a transfer of electrons from metals to non-metals, that has to be the transfer of what? The valence electrons of metals to non-metals. Now again, it's important to know that once this transfer has occurred, once an electron has been transferred from a metal, that metallic atom will become positively charged, while the non-metallic atom that accepted the electrons become negatively charged. Therefore, you have the formation of positively charged ions and negatively charged ions. The positively charged ions are called the cations, and the negatively charged ions are called what? The anions. Therefore, ionic bonding results in the formation of positively charged ions and negatively charged ions, which I have said they are what? Both cations and anions. Now, for what we are saying in summary is that if we say this is a metal, for instance, and this is metal that gives out an electron, it means that it becomes what? Positively charged. You can see this is, let's assume that this is an atom X, and this tells us what has happened, donation. Now a single electron is donated by this atom, and this atom becomes more positively what? Charged. Now if we take another atom, let's say we have another atom, this is atom Y, and this one accepts electron, a single electron, it becomes what? Minus. You can see this one is negatively charged while this is positively charged. Now because of the positive charge here and negative charge here, these are unlike charges. At every point in time you will expect, or there will be an attractive force between this positively charged and negatively charged ions, and so you now have something like this. There will be an attractive force, and that attractive force is what we call what? Ionic bond. So an ionic bond is simply an attractive force that exists between a positively charged ion and a negatively charged ion. And because this is positively charged and this is negatively charged, they neutralize themselves, and you now have what? This as what? The final product. And this final product is therefore called an ionic compound. Therefore, ionic compounds are formed as a result of what? Ionic bonding. Or electrovalent compound is formed as a result of ionic bonding. Please take note, when we look at covalent bonding, compounds are not formed. What you have is molecules. But for ionic or electrovalent bonding, what you find at the end, it's what? Compounds. It leads to the formation of compounds called ionic compounds. So now these I've described it with the X and Y. Let's take specific example. Now supposing we have a transfer taking place between sodium and chlorine. Sodium and chlorine. Let's look at that quickly. So let's quickly look at transfer of electron between sodium and chlorine. In other words, the ionic bonding between sodium and chlorine. Now, sodium, of course, it's a metal. And if it's a metal, it's going to donate a single electron. Remember that sodium has atomic number 11. If it has atomic number 11, this is the first shell will have minimum of 2 electrons. The next shell will have maximum of a single 8 electron, and the third shell will have what? A single what? Electron. So sodium, this single electron is what sodium will give out, and once sodium does that, it becomes what? Sodium plus. So for chlorine is an atom that has 17 electrons, 17 protons, 17 atomic numbers. So you now have 17, the atomic number of chlorine is 17, and that is 2. The first shell will have a minimum of 2 electrons, the second will be 8 electrons, and the last shell will have what? 7 electrons. Now, if this chlorine therefore will take the single electron sodium is donating, will be taken or accepted by what? Chlorine, and this will become what? Chlorine minus. Again, you know, you expect attractive force between the two of them, and this is what we call what? Ionic. This attractive force results in what? The ion. That's what we call the ionic bond. Now, if I put this together, it means that we have something like this: sodium plus chlorine, and that will give us what? Sodium chloride. If we are to describe this pictorially, what we'll have is this: sodium, the first shell is 2, the second shell will have 8 electrons. Now this is the outermost shell. The outermost shell will have just a single one electron. Now we take what? Chlorine. This is sodium plus chlorine. Chlorine, the first shell of chlorine will have us 2 electrons. The second will be what? 8. We are writing 2 and 8 inside, telling you that these are inner shells. There are shells that are there. Normally, there are supposed to be 3 what? Shells. 3 shells. Now, where here will be 2 electrons, here will be what? 8 electrons. While this will be what? 7 electrons. So here now I will be representing, let me use this not to represent it. You can see here 2 electrons are in the inner, 2 electrons are on the first shell, 8 electrons on the next shell, and then the outermost shell has just a single electron. That's why we say this is the same thing as 2, 8, 1. Why this one is 2, 8, 7. Now this is chlorine. This is chlorine atom. Now the chlorine atom combines with this. At the end, the final product will be, there will be a transfer. This electron will be transferred to this point, and once that electron is transferred, it means that this shell will no longer exist. This shell will no longer be there. We'll have only 2 shells, which is 2 and 8, and this is what I will represent. The first shell will not be 2. This is now the last shell that is left. Remember that the shell that has a single electron will no longer be there. It will be vacant, and we do not represent vacant shell. So that vacant shell will not be represented here. Rather, I will have only to represent the 2 shells, which is 2 and 8, and the first shell is 2. The outermost shell will now be 2, 4, 6, and 8. And of course, this is what we call the sodium word plus, sodium cation. Then the same thing happens here. Now for this, the shell, outermost shell is not removed, because the single electron that was transferred from here will as the single electron that's transferred from here will reside on the outermost shell, which is this shell. So the 2 8 shells are still intact. So we're going to have 2 8 shell, 2 on the first shell, 8 on the next shell. Of course, this will be on the K shell, and this will be on what? The L shell. So this is what? The M shell. So the L shell here originally had this. So we will represent them 2, 4, 6, then 7. This electron that is now transferred is what you have here. You can see now this is chlorine minus. Now you can now see that this is a chlorine cation, and this is, sodium cation, and this is chlorine anion. And this, of course, tells us when the 2 of them combine together, the charges here, of course, this charge will neutralize this charge. You now have what? The sodium chloride. So this is a description of bonding in sodium chloride. Now again, I want to emphasize that when these electrons are transferred from the metallic atom, that the number of electrons that is transferred must be the same that the non-metal is ready to accept. That's to say, if an atom wants to transfer 2 electrons from its atomos shell to another atom, those 2 electrons will be taken or accepted by another atom, a non-metal, that is ready to accept what? 2 electrons. So it means that if magnesium, for example, that wants to transfer 2 electrons, because magnesium has 2 valency, if 2 valencies of magnesium is to be transferred to chlorine will not be ready to take it, because chlorine can only take in only a single electron, can only accept a single electron. So for that transfer to be possible, it means that there has to be 2 chlorine atoms, where each of them will take one single electrons from what? Magnesium. Say magnesium is donating what? 2 electrons. So there will be an atom of magnesium combining with 2 atoms of chlorine, and that's the only way that bonding can take place. So let's take another example. Let's look at the transfer bonding between magnesium and oxygen. So let's quickly look at the bonding between magnesium and oxygen. Now magnesium is a metal that has 12 number of what? Electrons, 12 protons, 12 atomic numbers. How do I know the number of electrons? For me to know the number of electrons in an atom, you don't need to cram. You just remember what is the atomic number of that atom. The atomic number of magnesium is simply what? 12. Atomic number is the position of that atom in the periodic table. In the periodic table, the position of magnesium is 12. So if magnesium atomic number is 12, always remember that atomic number is always equal to the proton number, and is always equal to the electronic number. So the number of electrons must always be equal to the number of protons, and is also equal to the atomic number for atoms that are neutral. That doesn't apply to atoms doesn't apply to ions. For ions, the number of electrons are not equal to the atomic number, though the atomic number and proton number must equally be the same for ions, but they are not equal to the number of electrons. But for atoms, the number of electrons are equal to the atomic number and is equal to the proton number. That's how I knew that magnesium is 12, because I know the position of magnesium in the periodic table is 12. So the proton number must be 12. The number of electrons will equally be 12. So this again reminds me, I want you to know that whenever there is ionic bonding, we said ionic bonding will lead to the formation of what? Cations. It will lead to the formation of cations and anions. Now, what you will notice is that when sodium transfer its electron, remember, when sodium transfer its electron, it becomes sodium, from sodium atom to what? Sodium cation. Now, sodium cation, sodium atom, sodium cation. This atomic number here is still 11. The number of protons is still what? 11. The number of electrons here is 11. But for sodium, the number of atomic number will be 11. The proton, this is atomic number. The proton number will be, this is the proton number, will still be 11. But the number of electrons will be what? Number of what? Electrons. That is to say, electronic number. The number of electrons will be 10. The reason is that a single electron has been removed from what? Sodium. So you cannot see that for cations, the number of electrons will what? Reduce, depending on the number of charges here. If there are 2, if you have +2 here, it tells you that atom originally had transferred or has given out its 2 electrons. So whatever that is here, the atomic number will be less by 2. So, but for sodium, its atomic number, this is atomic number, this is proton number, and this is electronic number. You see that they are all what? 11, 11. They are the same. But when it comes to sodium, the atomic number is still 11, the proton number is still 11, but the number of electrons is 10. What is that telling you? What that tells you is that the character of an element or an atom that has donated its electron or accepted electron remain the same. Because the determinant of the character of or the property of an atom is what? The atomic number. So because the atomic number did not change from 11, it was 11 before the transfer, it was still 11 after the transfer, it tells you that the character of sodium will remain the same. Please, very important aspect, please. Every student should take note of this. Atomic number does not change. Their proton number does not change. It's only the number of electrons that changes when electrons have been transferred. And the atomic, the properties or the mass number does not equally change. Okay, that's just a digression. Okay, now let's quickly go back to magnesium. We want to describe the transfer or ionic bonding in the case of magnesium and oxygen. Now again, what is Again, atomic number of magnesium is 12. And if it is 12, it tells us that will be 282. That now tells us that the outermost shell will have 2 electrons. Therefore means that the valence electrons of magnesium is 2. That means magnesium will be donating 2 electrons. So I will now have minus 2 electrons, and that will give us what? Magnesium 2 plus. Now, because magnesium is donating 2 electrons, then these electrons can only be accepted by an atom, by a non-metal that is ready to accept 2 electrons. And that's why we are looking at oxygen. So for oxygen, this is oxygen. Oxygen has atomic number of oxygen is 8, and that will be what? 6. You can see that oxygen needs 2 electrons to make this shell 8. Remember that this is the K shell. This is the L shell. So the L shell for oxygen has 6 electrons. Normally, for it to be stable, the L shell must have 8 electrons. So oxygen therefore requires 2 electrons to make the L shell to become 8, which is why oxygen will take in 2 electrons, and that will become oxygen 2 minus. Oxygen 2 minus here is 2,8. That's what it is. Oxygen 2 minus is 2,8. Magnesium 2 plus will give us 8. You can see magnesium 2 plus will be 2,8 because these 2 electrons are given off. But for oxygen, this is 2,6. The 2 electrons are accepted or taken, and they must reside on the K shell. So it becomes 2,8. Again, you see 2 positively charged here and 2 negatively charged here, and so there will be an attractive force between the 2, and when that happens, you have what we call magnesium oxide. Magnesium oxide is an ionic compound, and again you can see that here it is neutral. It doesn't have any charge. The reason is that the charges here are neutralized each other, because plus 2 minus 2 will be 0. There will be no charge. So that's what happens in this case. So even if I chose to draw the treaty the other way, the first shell of this is 2,8. You have 2,8, where 2 here 8 on the first shell, this 8 on the second shell, the L shell, and then this one is the M shell, and it has only 2 electrons. Now how about oxygen? For oxygen, again, this is plus. This oxygen is 2, and then 6 electrons here, 2, 4, 6. Of course, this is oxygen atom, and why this is magnesium atom. Now the 2 of them are combined. This single electron will be transferred. Remember that this has 2 electrons. These 2 electrons, look at them. These 2 electrons will now be transferred to oxygen, and when that happens, it means that this shell will no longer be there, because the 2 electrons on the shell have been moved away, or they've been transferred. So you will now have only 2 shells. 2 shells will be left, which is this shell and this shell. So in this case, I want to represent only this shell. So this has to be inside, while the 8 here will be on this shell. That will be 2, 4, 6, and 8. Of course, this will be magnesium 2 plus. Then plus the oxygen here will accept these 2 electrons. So we're going to have the first shell, the inner shell will be 2. Here is already 6 electrons, 2, 4, 6. Then these 2 electrons that are transferred, they will now reside here. I see this is now oxygen 2 minus. So if you represent this pictorially, this is what you have. So you can now see that this again the transfer of electrons from magnesium atom to what? Sodium to oxygen atom, and that led to what? The formation of magnesium oxide, while the first one we did was that of sodium, leading to the formation of what? Sodium chloride. So you can see the hallmark of all of this is that the transfer has to be from a metal to what? A non-metal, or from an electropositive atom to an electronegative atom. So now at this point, it's also you can think of many examples. So for all the elements that you find within group 1 and group 2, those elements are metallic elements. Group 1 and group 2 are the most electropositive elements, and so they would likely be combining with group 7 and group 6 elements. So the more electropositive the metal is, and the more electronegative the element the non-metal is, the stronger the ionic. Having discussed electrovalent bonding, let's quickly look at the properties of ionic bonds or ionic compounds. You know that the product of ionic bonding is the formation of ionic compounds, and these ionic compounds have properties. So these are the properties we want to quickly discuss. The first property is that ionic compounds are soluble in polar solvent like water. Polar solvents are those solvents with a lone pair of electrons. So when you put an ionic compound in a polar solvent, it dissolves. For example, sodium chloride is an ionic compound. When it's dissolved or put in water, you see it dissolves immediately. Now also another property of ionic compound is they are very conductive. In other words, they conduct electricity in solution or in molten state, which is why they are used as electrolytes. The ionic compounds also have high melting and boiling point. This is the reason why most of the compounds exist in solid at room temperature. So these are the three properties of ionic compounds. Sometimes in exams they want to test your understanding of these properties, but they do so by asking you to explain or compare the ionic property of two ionic compounds. For example, if I have sodium chloride and magnesium chloride, and you're asked, for instance, to say between the two compounds which one is more ionic, which of them is more ionic, which of them is more conductive, or which of them will have a higher melting and boiling point. Now it's a simple question, but that's what you find in most examination. Now when you have a question like that, look at the two compounds. You notice that the non-metal in the two compounds is the same. We have chlorine here, we have fluorine. That means electronegativity is constant. And again, I want you to understand that for such question to be answered, you must understand that the ionic strength, the strength of the ionic bond. Remember that ionic bond is, if I have sodium chloride written like this is the ionic bond. The ionic bond. If sodium chloride is written like this, even if I decide to write magnesium chloride this way, this is the ionic bond. Now the strength of this bond, it determines or depends on the electropositivity of the metal as well as the electronegativity of the non-metal. Remember, in every ionic compound you have an electropositive element, you will have an electronegative element. Now the electropositivity of that metal as well as the electronegativity of the non-metal determines the strength of that bond. In other words, this bond will be stronger if this metal is very electropositive or if this non-metal is highly electronegative. Now look at the two compounds, sodium chloride and magnesium chloride. You notice that this chlorine and this non-metal is a chloride non-metal, and here also a chloride non-metal. Now what is different? The difference between these two compounds is the sodium and the magnesium, the metal. And so you now need to ask yourself, between the sodium and magnesium, which of them is more electropositive? Please, to answer that, electropositivity decreases from left to right along the period of a periodic table. Now it means that for you to know whether sodium, or for you to decide whether sodium or magnesium is more electropositive, you have to ask yourself, what is their position in the periodic table? In the periodic table, you know that sodium itself is 11, and that is 281, while magnesium is 282. This tells us that the two of them belong to the same period but different groups. You can see that 1, 2, 3 tells us sodium has 3 shells. 1, 2, 3 tells us that magnesium has 3 shells. Having 3 shells, they both have 3 shells. That tells us, or that means that they both are in the third period. And if they are in the third period, what about the group? You see that sodium is in group 1, while magnesium is in group 2. So supposing I have this to be, let's say this is period 3, this period 3, it means that sodium is here and magnesium is here. Where here is group 1 and here might be what? The group 2. So you can now see, as you move from left to right, you will need sodium first before magnesium. It means that sodium is more electropositive than what? Magnesium. Remember we said that as you move from left to right, electropositivity does what? Decreases. And so the electropositivity of magnesium will be less than that of what? Sodium. It therefore means that this compound is more ionic than this compound. This compound is more conductive than this compound. This compound must have a higher melting point and higher melting point than this compound. If the two of them are to be used as an electrolyte, this one will be more conductive. Very important question. So it means that anytime you have such a question, you must ask yourself, you have to compare the electropositivity or electronegativity of the two elements that are involved. But in this case, the electropositivity is not considered because it is constant. How about if we have an element, a compound like sodium chloride and sodium iodide? Now in this case, the elements here, the metal here is sodium, the metal here is sodium. You can now see that electropositivity in this case is constant because the same element is present in both compounds. But what is different here is the non-metal. Here we have chlorine, here we have what? Iodine. Now you begin to ask yourself, between iodine and chlorine, which of them will be more electronegative? The one with the higher electronegativity tells you that compound where it is will be more ionic, that compound will be more conductive, that compound will have a higher melting point. So that's how you answer such questions. Sometimes they can ask you, arrange the following in order of increasing conductivity. For instance, you're given a compound like, let's say, sodium chloride, potassium chloride, and then magnesium chloride. And you're asked to arrange this in order of increasing conductivity, or in order of increasing ionic bond strength, or in order of increasing melting point, or in order of what? Increasing solubility. Now that's all those things I've mentioned are properties of an ionic compound. So what you need to do in this case, you simply ask yourself, among all of them, which one is more what? Electropositive. Sodium will be more potassium will be more electropositive, next will be what? Sodium, and next will be what? Magnesium. The reason is that sodium and potassium are in group 1. But sodium is up while potassium is what? Down. And as you go down the group, electropositivity increases, while as you move from left to right, electropositivity decreases. So if you want to have understanding of the electropositivity, atomic size, ionic size, ionization energy, these are all periodic properties of elements. If you want to have understanding, then go check for my videos. I have done a video on that, on all of these properties, and you will see how they varies across and down the group of the periodic table. Now for this example, or for this question, where you're asked to arrange these 3 compounds in order of increasing ionic strength, in order of conductivity, in order of increasing melting and boiling point, like again, as I said earlier, that in this case, electronegativity is constant because it is the same element that is here, that same element is here, that same element is here. But what is different here is what? The metal. Here we have sodium, you have potassium, here is magnesium. You now ask yourself, between sodium, potassium, and magnesium, which of them is more electropositive? And I said it is potassium, because if you arrange these elements, sodium, potassium, magnesium, in the periodic table, you see that magnesium is in group 2, sodium and potassium are in group 1. That means sodium and potassium will be more electropositive than magnesium. But between sodium and potassium, which of them is more electropositive? Again, the answer is potassium, because in group 1, potassium is down while the sodium is up there. And so when you go down that group 1, you expect electropositivity to do what? To increase. Therefore, we say potassium is more what? Electropositive. So if I'm to arrange this, I can say that potassium chloride is more electropositive than sodium what? It's more ionic than sodium chloride, and this is more ionic than what? Magnesium what? Chloride. This is in order of what? Increasing ionic strength. So if for instance I make an arrow this way, this arrow is in what? Decreasing solubility, decreasing conductivity, decreasing melting point. All those properties of ionic compounds we've identified. For these 3 compounds, those properties will be decreasing. So at this point, I want to believe that I've made you understand the topic ionic bonding. So if you have any complaint, any question, please go to the comment section and drop it there. I will respond. Don't also forget to share and like this video. Again, I want to tell you that I've done videos on covalent bonding, metallic bonding, and periodic properties. So always go check that. That's why I ask or request you to subscribe, and also turn on the notification bell, so that once new videos are made, you'll be notified. Thank you.